Hey everyone, today let's talk about a word we hear all the time, science. But what does it really mean? It's way more than just a dusty old textbook full of facts. As we're going to see, it's a powerful toolkit for thinking, a way to be creative, and really, a deeply human way of making sense of our world. So let's dive in. All right, let's kick things off with a huge one. You've probably heard someone dismiss an idea by saying, "Oh, that's just a theory," as if it's some random guess. But is that really what a scientific theory is? Yeah, not even close. And you can see right here, there's this massive gap between how we use that word in daily life and what it means in science. To us, a theory might be a hunch, an idea. But in science, a theory is an absolute powerhouse. It's a gigantic explanation. Think atomic theory that has survived endless testing and is backed by a literal mountain of evidence. It's one of the strongest tools for understanding we have. And that actually leads us to our first major point here. Science isn't some list of facts that never ever change. Nope. It's a living, breathing process of discovery where our ideas are constantly being put to the test and refined. Okay, so to really get that process, we've got to talk about the difference between a theory and a law. A scientific law, like the law of gravity, just describes what happens. It tells you, hey, if you drop an apple, it's going to fall every single time. But it doesn't tell you why. That's where the theory comes in. A theory is the deep dive, the explanation behind the patterns we see. And this right here is the absolute heart of science. The explanations are never set in stone. Think about it. When a new piece of tech comes along, like the telescope, it suddenly opens up a whole new window on the universe. We get brand new data, and that new evidence can force us to completely change or even toss out old ideas. And that's not a weakness. That's science's greatest strength. So, how does all this work in the real world? I mean, we all learned about the scientific method in school, right? That super rigid step-by-step list. But honestly, the reality is way more flexible. It's less like a single recipe and more like a whole toolkit with different tools for different jobs. So, the first tool in that kit is what we call a descriptive investigation. Sometimes the whole point is just to ask, what's actually out there? It's all about looking closely, observing, and gathering details to describe the world just as it is. So, picture this. A geologist is out in the field, standing in front of a giant cliff face. They're not testing some big idea just yet. They are carefully, meticulously observing, measuring, and writing down everything about the different layers of rock. That basic description, that's the crucial first step before you can even start asking deeper questions. All right, let's grab the next tool from our toolkit and see how this all connects. This is the comparative investigation. Now we're shifting gears a bit. Instead of just describing one thing, we're comparing two or more things to see how they're alike, how they're different, and maybe find some interesting relationships between them. And you know what? This is something we do constantly without even realizing it. You ask a simple question like, did we get more rain this year than last year? Well, that's a comparative investigation. You're gathering data from two different sets, this year's rainfall, last year's rainfall, and you're comparing them to find the answer. And last but not least, we have the one most of us think of when we hear the word science, the experimental investigation. This is where you get hands-on and actively test an idea, a hypothesis, by setting up a controlled test to see if what you predicted actually happens. Okay, so let's put this into practice. How do we actually go from just having a question to finding a solid conclusion? Let's test an idea with a problem I'm sure we've all faced. The classic ketchup stain. Your mom swears that old school vinegar is the answer, but you're thinking, come on, modern detergent has to be better. So who's right? You've got your question, and now you need a fair way to find out for sure. The absolute key here is to run what's called a controlled experiment. See, if you want your results to actually mean something, you have to be super systematic. That means you can only change one thing at a time, in this case, the cleaner, while keeping everything else exactly the same. Oh, and you also need a control, something to compare your results against. And this setup is what makes it a real experiment. You've got three identical stains on the same shirt. One gets the vinegar, one gets the detergent, and the third one? You do nothing. You leave it alone. That is your control. It's your baseline. It shows you what happens with no treatment at all. Now, after you wash it, you can actually compare the results and make a real conclusion based on evidence, not just an argument over the dinner table. You know, This whole process isn't just for sterile labs or, ketchup stains. It's a deeply human thing, driven by people. And scientists are not these one-dimensional stereotypes in lab coats. They're creative, they're curious, they're incredibly diverse people. I mean, just take Mae Jemison. If you have a specific picture in your head of what a scientist is, her story is going to blow that wide open. I mean, just look at this list. Mae Jemison was passionate about dance and theater. She also became a chemical engineer, then a medical doctor, and then, oh yeah, the first Black woman to go to space. Her creativity wasn't some separate hobby. It was part of her science. It fueled it, giving her this totally unique perspective on the medical experiments she was running up in orbit. But no matter who they are or where they come from, all real scientists are guided by one fundamental principle. And this quote really nails it. Their work has to be based on facts. Their claims aren't just opinions or biases or something they imagined. And that core idea leads to a few essential habits of mind that are just crucial for doing good science. There's intellectual honesty. That means you're committed to the facts, not your personal feelings. Then there's skepticism, which means you question things, not to be a downer, but to make sure that claims are really, truly solid. You have to be open to new ideas because you never know where the next big breakthrough is going to come from. And above all, you use critical thinking to logically connect all the dots. Okay, so why should we care about any of this? Why does it matter in our everyday lives? Well, because we are flooded with information every single day. And this way of thinking is our best defense, our best tool for telling the difference between what's real and what just sounds real. All right, let's look at a classic example of what we call pseudoscience, something that dresses up like science but isn't. I'm sure you've heard this one, the claim that the Giza pyramids were built to align perfectly with the stars in Orion's belt. Sounds pretty amazing, doesn't it? But hold on, this is where that scientific thinking has to kick in. The pseudoscience claim is based on just one thing. They look like they line up today. But a scientist asks a deeper question. Okay, but did they line up when they were actually built? Because we know for a fact that stars move in the sky over thousands of years. And guess what? When astronomers rewind the clock to when the pyramids were built, that alignment completely disappears. The evidence just isn't there. And that, right there, is the difference. So you see, in the end, science isn't some exclusive club. It's a mindset that belongs to all of us. It's a toolkit for our own curiosity. It's about asking good questions, being a little skeptical of the easy answers, and having the courage to follow the evidence wherever it might lead. So I'll leave you with this. What part of your world are you going to look at with a scientific mind today?